Chapter 2, Number 40. Landing with a speed of 71.4 meters per second and traveling due south, a jet comes to rest in 949 meters. Assuming the jet slows with constant acceleration, find the magnitude and direction of the acceleration. So we draw a picture, and we have a plane that lands with some initial velocity. Here it's 71.4 meters per second, and then it comes to rest somewhere else, and we know that if this position is 0, we'd like to figure out where does it end up. We also would say the time is 0, and we might want to know what is the time. But really what we care about is the acceleration, which must point opposite to the velocity because it is getting slower. In this thing, although I've written it, we are neither given the time nor interested in the time, so really they're not that useful. And that immediately points me towards the equation that v squared is v0 squared plus 2a x minus x0, because that neither has nor cares about the time information. Remember, this equation can be derived by basically taking the other equations and solving for the time and then plugging in and eliminating them. But you don't have to do that ever. You can start from this as a guaranteed first thing. And so we can say here that we have 0 squared is, and here we have whatever the initial velocity squared is, plus twice times the acceleration, times where we end up, minus where we start. This is v0 squared plus 2axf. That allows me to solve this equation to say that a is minus v0 squared over 2xf, or minus 71.4 meters per second all squared over 2 times 949 meters, which is minus 2.69 meters per second squared. And we notice that the minus sign confirms for us that we're going opposite to our velocity. We're moving in this case, northward direction, since the velocity was southward.